Welcome to the section on balancing equations, otherwise known as application of the law of conservation of mass. When you're balancing equations, the law of conservation of mass comes into play. This law states that you can neither create nor destroy matter in a chemical reaction, which means that the total mass you start with must equal the total mass that you end with. Or put it in another way, the total number of atoms of an element you start with must equal the total number of that element you end with. So we're going to use some vocabulary, and for this we're going to start with a simple equation. And the first thing we have is in yellow, and that is very cleverly called the arrow. Now we have the elements in blue. Those are the reactants. Everything to the left of the arrow is a reactant. Then we have the material in green, and those are products. Everything to the right of the arrow is a product. Next we go with gray, and those numbers below the line are called subscripts. And lastly we have the pink, and those are the numbers in front of some of the chemicals, and those are called coefficients. So we have reactants, products, subscripts, and coefficients. There are rules. Rule number 1. You may only use the chemicals present in the reaction when you first write it. You may never change a subscript because that changes the chemical, and now you need to go back and reference rule 1. You are only allowed to change the coefficient. When you are done, the coefficients must be in the lowest whole number ratio, and we are conserving atoms, not moles. So moving on, here's a simple equation. Methane, or CH4, is allowed to react with oxygen, and this produces carbon dioxide and water. And we're going to do this visually, and we're going to keep track of the reactants and the products. So we're going to make the carbon blue, and we see that on the product side and the reactant side we have 1. That's actually balanced. Then we look at the oxygens. We'll put those in red, and we see that on the reactant side there are 2, but on the product side there are 3. This is most definitely not balanced. And then we look at the hydrogen, which will be in yellow, and we see that on the reactant side there are 4. On the product side there are 2. That's not balanced. As a matter of fact, the reaction is balanced only when the numbers on both sides for reactant and product are equal. Now what we need to do is balance this, and so we're going to pick an element to balance. The carbon is already balanced, so we're now going to do that. And the oxygen is by itself, so it's the easiest thing to balance. So we'll actually start with the hydrogen. I have 4 on my reactant side. I need 4 on my product side, which means I need 2 more, which means I need to add another water because all the hydrogen on the product side is due to water. So I add another water molecule, and now I count everything up, and I see that I now have 4 hydrogens on the product side, but I now have 4 oxygens on the product side. So now I have my carbon balanced and my hydrogen balanced, but my oxygen isn't balanced. And in order to balance my oxygen, I need more oxygen on my reactant side, and that has to be added as O2. When I add another O2, I now have 4 oxygens on my reactant side and 4 on my product side. And as a matter of fact, I notice that now the numbers on the reactant side are the same as the numbers on the product side. We say that we have now balanced the equation. So on those little dashed lines, we now put how much of each molecule we have. We have 1 methane, 2 oxygens, 1 carbon dioxide, and 2 hydrogens. I tend not to write the 1s. As a matter of fact, most chemists don't write the 1s. And when I wrote it out, my final balanced equation would look like this. Let's look at another one. I'm going to do the same thing. Reactant, product, and now I'm just going to start counting atoms. Sodium will be in purple. We have 3 on the reactant side and 1 on the product side. For the phosphorus, we have 1 on the reactant side and 2 on the product side. For the oxygen, we have 4 on the reactant side, but 8 on the product side. Calcium, we have 1 on the reactant, 3 on the product side. And for the chloride, we have 2 on the reactant side and 1 on the product side. So looking at this, nothing is balanced. So you pick an element and you start balancing. I'm going to start balancing the sodiums. I need 3 on the product side, so I add 2 more sodium chlorides, and that now gives me 3 sodiums, and it gives me 3 chlorides on the product side. But I see that my sodium is balanced. Now I need to balance something else. I'm going to pick phosphorus. I have 2 on the product side, 1 on the reactant side, so I add another one to the reactant side. When I do that, I find out that I've unbalanced my sodium. That's okay. I now have 6 on the reactant side. I have 2 phosphorus on the reactant side, and I have 8 oxygens on the reactant side. So actually now my phosphorus and my oxygen are both balanced. Now I need to pick something else. I could pick the sodium, I could pick the chloride, but the calcium looks easier. I've got 1 on the reactant, 3 on the product, so I'm going to add more of the calcium chloride. I'm going to add 2 more, so I have a total of 3 calciums now on the reactant side, and now I have 6 chlorides on the product side. So now my phosphorus, oxygen, and calcium are balanced. Now I'm going to balance the chloride. I need 3 more on the product side, so I'm going to add 3 more sodium chlorides. When I do that, I see that I now have 6 sodiums and 6 chlorides. Both sides now have the same numbers. I am balanced. It took me 2 sodium phosphates, 3 calcium chlorides, 6 sodium chlorides, and 1 calcium phosphate. And so I would write it this way. Parenthetically, if you keep the ones in the reaction, it won't be marked wrong. But this shortcut is valid only if the polyatomic ion is exactly the same on both sides of the arrow. Then you can treat it like an element. Let's do the last one again, but since the phosphate is present on both sides, I'm going to treat it as a single entity. I'm going to look at my reactants and products. 3 sodiums in the reactant, 1 on the product side. Now I'm going to look at the phosphates. When I do that, I see that I have 1 on the reactant side and 2 on the product side. Go to the calciums, where we have 1 and 3, and then the chlorides, where I have 2 and 1. Now I'm going to do the same thing. I'm going to balance the sodiums, which is on the product side, I now have 3 sodiums and 3 chlorines. Now I'm going to balance the phosphate. In order to do that, I have to add a phosphate to the reactant side, so I add a sodium phosphate. You must add the entire chemical. When I do that, I now have 6 sodiums, but I have 2 phosphates. The phosphate is balanced. I add 2 more calciums, so now I have 3 calcium chlorides, which means I have 3 calciums and now 6 chlorides on the reactant side. I add 3 more sodium chlorides to the product side, and I now have 6 sodiums and 6 chlorides. And once again, I end up with the same reaction, the same coefficients. I'm balanced. So in review, you can only use the chemicals present in the reaction. Never change a subscript. That changes the chemical, and then I refer you back to step 1. Only change the coefficients. That's the number in front of the chemical. The coefficients must be in the lowest whole number ratio. When you're done, you should have the same number of atoms on the reactant side that you have on the product side. Now the rest, as I said, is practice. Go out and practice.